we're going to use, we talked about the graphing process and then how to use your graph to figure out the corner points and find your maximum and minimum value. Okay, so we just talked really about the general process. So now we're really going to get into what it's used for. Okay, so linear programming is used to find the optimum solution to a situation. Okay, so let's just read through this problem together. Your club plans to raise money by selling 2 sizes of fruit baskets. The plan is to buy small baskets for $10 and sell them for $16, and to buy large baskets for $15 and sell them for $25. The club president estimates that you will sell no more than 100 baskets. Right? You don't want to buy a bunch of stuff and then not sell it and then have all this left over and you're going to lose money. Okay, so they're saying 100 baskets, that's the limit. Your club can afford to spend only $1,200 to buy them in the first place. So what we want to do is figure out, okay, what should I buy? How many of each should I buy if I want to make the most money for my club here? Okay, so when we're doing this, the first thing you always want to do is set your variables. Okay, and your variables are what you are using to maximize your situation. Okay, so in this case, we're trying to maximize our profit by selling fruit baskets. So our variable should be what? What should our variables be?
Could be X's number of baskets and Y's total cost.
Well, my cost isn't a variable because my cost is dependent on what I'm selling. So let's see. So we're looking at the baskets. Small and big. We're selling small baskets and large baskets. I need to know how many of each I should sell to make the most money. Okay, so those are going to be my 2 variables. X is going to be small baskets. And Y is going to be large baskets. Small baskets and large baskets. Okay, so the next thing that we are going to do is get all of the information in here organized so that we can write our constraints, okay? The first 2 constraints that you should always write, they're honestly the easiest, but they're the most forgotten because it's just kind of self-explanatory, you would think. Your first 2 inequalities should always represent your restriction on the individual variable. Okay, so here's what I mean by that. The restriction on the individual variable. So that means that one inequality should just have an X and one inequality should just have a Y. Okay, so the restriction on the individual variable. Is there anything in this problem that says, for example, we have to sell at least 2 small baskets? Is there anything that says we can't sell more than 10 large baskets? Is there a restriction on an individual variable? No. Okay, so what does that mean? Can we sell a negative amount of something? No. So what's the smallest number of each type of basket that we're going to sell? 0. Okay, we're either going to sell none of it or we're going to sell more. So the first 2 restrictions, I would say 9 out of 10 times, these are going to be your first 2. If there's not a restriction on each individual variable, you have to specify that the smallest amount you're going to sell is 0. Okay? So now what we're going to do is we're going to figure out what my other 2 restrictions are. Okay? So we're going to read through the problem. Do it by yourself for a second. Raise your hand when you see something that could be described as a restriction for this situation. So I want everyone to read through it again. And I want you to raise your hand if you see something that I could describe as being a restriction. I'm going to wait for at least probably 8 people to raise their hand. Raise your hand when you see something that could be described as a restriction. Okay. Lauren, tell me what you see. We can't spend more than $1,200. I'm just going to put a box or something around it. Okay, we can't spend more than $1,200. So that means that something about our small baskets plus something about our large baskets has to be less than or equal to $1,200. Okay, well, let's fill in those blanks. Okay, so if this represents the money that you have to spend, these 2 blanks right here should represent how much we have to spend on each. So we go back up here. So if we're looking for how much to spend, I see it costs $10 to buy a small basket. So $10 times X. And then I see that it costs $15 to buy a large basket. That's how much we have to spend. So $10 per small basket, $15 for large baskets. That has to be less than or equal to $1,200. Okay. Raise your hand if you see another restriction. And I'll wait for. Raise your hand if you see another restriction. Natalie, go for it. You're going to sell no more than 100 baskets. So between the 2 baskets, between the 2 types, you're not going to sell more than 100. So you have something plus small plus something about large has to be less than or equal to 100. Well, if we're just talking about the sum of the 2 baskets, what should go over here? What should go over here? X, just X and Y. So the total number, that's just the sum. So the 2 types of baskets together have to be less than or equal to $100. Okay. Does anybody have any questions about the constraints? The constraints are your inequalities. They always represent restrictions. The first 2 are on the individual variable, so just an X and just a Y. The other 2 or 3, however many you have, come from your problem. I don't see any other restrictions up here. So these are my 4. The objective function, remember from last class, that's the equation that you use to describe the maximum or minimum situation. So if we're trying to write an objective function for the company's profit, we want our equation to represent that profit. Okay, so then we kind of look back up, well, what information haven't we used yet? Well, I see that we haven't really used this, the $16, and we haven't talked about the $25 yet either. So that's going to help us figure out how much we're going to make. Remember, the profit on something, though, is the difference between what you spent and what you made. So if I'm wanting to know the profit, if we bought baskets for $10 and sold them for $16, what would our profit on the small baskets be? $6. And then if we bought the large baskets for $15 and sold them for $25, what would my profit on the large baskets be? $10. So that's going to be my objective function. So this club is going to make $6 for every small basket I sell and $10 for every large basket they sell. Okay. So this is all the work that was done for us last class. Okay, so we've done all of the graphing stuff together. Okay, the only thing that I'm going to change is because of this situation and these values, changing your equation into slope-intercept form could actually cause more problems when you're graphing it. So we are not actually going to graph it in slope-intercept form. We are going to graph using the intercepts, which we talked about on the very first day of school. We're just going to review it really quickly. And that's one of the reasons why I wanted to do that problem in the warm-up too. So if I'm looking at my first inequality here, if I want to know where this line is going to cross the x-axis, the value of y is going to be 0. So if I essentially get rid of that term, because that's what's going to happen when I make y 0, I want to figure out what x is. So 1200 divided by 10 is going to be 120. So the x-intercept for this equation is going to be, let me get a different color, it's kind of hard to see, is going to be 120. So then I want to find what the y-intercept would be. So at my y-intercept, the value of x is 0. So that makes that term go away. 1200 divided by 15 is 80. Okay, so eventually when I graph it, that's how I'm going to graph this line. I'm going to plot 120, I'm going to plot 80, and then I'll connect my points. So then for this next one, I'm going to do the same thing. If I want to find my x-intercept, that means the value of y is 0, so that term disappears. So my x-intercept here would be 100. The y-intercept makes the value of x 0, so that goes away. The value of y is also going to be 100. So this next part is honestly one of the harder things for people to figure out because it's just something that you guys haven't really had to do very much of. And so what that is I gave you guys a blank graph, right? Based on my first two restrictions, that x and y are both greater than or equal to 0, what quadrant does that put me in if x and y are both positive? The first. So I don't have to draw like the whole cross. I can just label the y-axis and the x-axis, make those both positive. When you're doing these, you want your graph in this space to take up as much room as possible. So you don't want to make your intervals too small, or else your feasible region is going to be really small and you're not going to be able to see what you need to see. Okay? So we want to make our graph, we want to make our intervals as big as possible. We want our interval to go into both intercepts. Okay, so what I mean by that is like I wouldn't want to make my x interval 25 because 25 doesn't go into 120. Okay, so you want each tick mark to represent something that goes into each intercept. You can also make each intercept different. So if you want your x's to go up by 5, your y to go up by 10, that's okay. That's allowed. Okay, but you want to stretch it out as much as possible. Okay? So when I'm thinking about what I have enough space for, I see that I need my interval to go into both 100 and 120. So think about the smallest number possible. So for the first one I think about is maybe 5, but I don't think I'm going to have enough room for that. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 60, 70, 75, 80, 85, 90, 95, 100, 105, 110. So I don't have enough for that because I need to go up to 120. So then the next thing that I think of is maybe 10 as being my interval, and that's going to work. I know I'm going to have enough space for 10. So I'm going to start that at 0 right here. That would be my origin. And then I'm going to make each tick mark go up by an increment of 10. And we can stop at 120 since that's our biggest value for x. I don't need to graph higher than that. So it looks like, again, for my y's, I need to be able to hit 80 and 100. So we could go up by 10 again. We could even go up by 5. We have enough room to go up by 5s here. So I'm going to do that just to spread everything out a little bit. But just to save myself some writing, I'm only going to label every other one. So I'm going to go up by 5, but just label every other one. So 5, 10, and then 15, 20, 30, 40, 50, 60, 70, 80, 90, 100. So your intervals are not necessarily always going to be the same. They're not even necessarily going to be the same as the person sitting next to you. But you need to make sure that they work for your problem, or else you're going to create more work for yourself in a second, which we'll talk about. Okay. All right, so now let's use our intercepts to get these graphed so that we can see what our feasible region is. And remember, the feasible region is that shaded area. All right, so for my first inequality, my x-intercept was 120, and my y-intercept was up here at 80. X-intercept was 120, my y-intercept was 80. My next inequality had an x and y-intercept both at 100. So when I find my feasible region, that's going to be the area that makes both of these true. I'm less than both of these lines, so I would shade down here for this one, and then down here for that one. So that's going to make this little area my shaded region. So I'm below both of these lines, so if you need to get in the post-its, I've got post-its still in the back. I just used my ruler to cover up one, and then my hand to cover up the other. But I'm less than both of these lines, so that little area is going to be the feasible region. So the next step in this process is to use our corner points and the objective function to find what's going to give us our maximum profit. Okay, there are 3 corner points that should be very easy to determine. So that would be the y-intercept, which is 0, 80. The origin, which is 0, 0. The x-intercept, which is 100, 0. The fourth point of intersection is always going to be where your 2 lines intersect. I'm sorry, the fourth corner point is always going to be where your 2 lines intersect. So here is one example why choosing your intervals is extremely important. Because in the best case scenario, these points will intersect right at a corner. So it looks like this point of intersection is 60, 40. But of course, human error is always a possibility. Okay, so you always want to check this point of intersection. What I mean by check is plug this point, this x and y value, into your constraints and make sure that it's true. So is 10 times 60 plus 15 times 40 equal to 1200? Yes. Is 60 plus 40 100? Yes. So we know that that point is correct. Okay? Let me say one more thing and then I'll ask your question or answer your question. Let's say that our intervals weren't good or we made a mistake graphing and that point didn't work out. What have we done this year that represents where 2 lines intersect? What would we have to do with these 2 equations to figure out what that correct coordinate is? You guys just took a quiz over it. A system of equations. Okay? When you solve a system of equations using substitution or elimination, you're finding the point of intersection. Okay, so if your point is not correct, you need to check it. You will need to set up a system of equations and do substitution or elimination. So if you graph it wrong and you do not check that point and you get the answer wrong, there's not a whole lot I can do to help. Okay, so make sure you are checking your work. Okay, so after we do this, we plug these 2 or 4 coordinates into our objective function because that's what tells us that we are going to, or what we need to do to maximize our profit. So 6 times 0 plus 10 times 80, and I didn't need to type in the 6 times 0. So that's going to give us 800. So this situation gives us a profit of $800. Obviously, if we sell 0 of either basket, we're going to make $0. If I sell 100 small baskets, 6 times 100 is $600. That would be my profit here. And then 6 times 60 plus 10 times 40 is $760. Okay, so these are my 4 scenarios. If I'm trying to maximize profit, it looks like this is what I'm going to want to do. So your conclusion, oh, Ella, I just realized too. Did I answer your question or no?
No.
Okay, before I write my conclusion, what was your question?
I was going to ask if you could set the 2 equations equal to each other to find the point of intersection, or if that wouldn't work.
No, that would work perfectly because that is essentially solving your system when you set them equal to each other. The thing you would need to do is like you would need to make this like y equals negative x plus 100 and then solve for y here, and then you'd set your equations equal to each other. Okay, so you would need to do a little bit of background work before you did that. But yeah, when you set two equations equal to each other, that's what you're doing. Caleb, what was your question? I'll just
I was thinking for C, wouldn't it be 16x plus 25y? Because you're trying to find the club's profit.
But you're trying to find the profit, so that's going to be the difference between what you spent to buy the baskets and what you're making on them. So if you spent $10 to buy the basket and you're selling them for $16, you're making a profit of $6. Does that make sense?
Yeah.
Okay. If you did that, you would still get the same, like this would still be the maximum value. This money value would just be a little bit different. Okay. So our conclusion then, we would think back to what we made each variable represent. This was our small basket, this was our large basket, so our conclusion would be the club should buy 80 large baskets. And no small baskets. Okay. Bless you. Are there any questions before we move on to the next problem? The more practice you guys get with these, the faster they will get. I promise you. It's just like anything else. The first time is new, so I went slow to make sure I explained everything. We'll kind of break this next one up into chunks where you're trying some things on your own, and then you guys will work through the last one. Okay? All right, so let's read through this one together. We'll come up with the variables together, and then I'll give you guys a little bit of time to try to write the constraints on your own. All right, so Mary works selling cards over the telephone. She's one of those annoying people that calls you, tries to sell you stuff. She sells two types of cards, birthday cards and holiday cards. Mary makes $2 for each pack of birthday cards she sells and $2.50 for each pack of holiday cards she sells. She can work no more than 10 hours per week. This is their little sidekick here. She can only work 10 hours per week. It takes her about 15 minutes before someone buys a pack of birthday cards and about 20 minutes before someone buys a pack of holiday cards. She cannot sell more than 35 packs of cards. So that's how much she has in her stockpile, so she can't sell more than 35. Okay? So if she wants to make the most money, how many of each type should she sell? So in your groups, talk about what the two variables should be, and then write the 4 constraints. Ooh.
I'm just like going home, but like, is it okay if I join the Zoom call?
Oh, absolutely, yeah. All right, so let's talk about what your what your four constraints should be. Well, I guess first we need to figure out what the variables are. Okay, so Savvy, what did you guys say the variables were?
You said X was birthday card and Y was holiday card.
Okay, so X is birthday, Y is holiday. All right, so if you did the opposite, that's okay, but just be aware then that everything from here on out is going to be switched. So if you had the variables switched and you want to just keep it consistent to what we have, you might want to just change it, but it's okay. Either way is fine. Okay, so again, your first two constraints are just for X and just for Y. Just for X and just for Y. Is there a restriction on the individual amount of birthday cards that you have to sell? Of just birthday cards? Okay, so let's do that one then. So if we're talking about all of them, that's the two put together. So that would be X and Y have to be less than or equal to 35. So that should be one of them. Okay? So it doesn't say packs of each type of card. It says total she can't sell 35. So Natalie, does it make sense why that gets put together? So let me ask the question again. Is there a restriction for the individual amount of cards that we have to sell? No. Can we sell a negative amount? Nope. So what should go on the other side of that inequality? 0. Okay? That's the lowest number she's going to sell. She's either going to sell 0 or she's going to sell more than 0, but the total amount of cards together cannot be more than 35. Okay? Jasmine, what was the other restriction in this problem? So you don't have to give me the inequality, just give me the other restriction that we have. She can only work 10 hours per week. Okay, so then we want to say, all right, something about birthday cards plus something about holiday cards has to be less than or equal to 10 hours. That's the maximum amount of time she has to work. Okay, well, John, how much time does it take for her to sell a pack of birthday cards? 15 minutes. Okay. And Kaylee, how long does it take her to sell a pack of holiday cards? 20 minutes. Okay. So would this be my inequality? No. What's wrong with this? And so, well, it's not going to be more because 10 is the maximum amount she has to work. So that total amount of time has to be less than 10 hours. So what do you have a problem with? You could definitely do that. I would steer, it would still be less than or equal to. That would be okay. I would steer clear of the fraction. So if you want to do that, that's fine. I try not to work with fractions if I don't have to. So Natalie, what would my other option be? Exactly. So you converted the minutes to hours. That's where you got the 1/4 and the 1/3 from, which is awesome. I am going to change this to minutes so that I don't have to worry about fractions. So regardless, your inequality all have to be in the same unit. So since this is in minutes, this is in minutes, this has to be in minutes. Or if you keep this hours, this would be 1/3 of an hour. This would be 1/4 of an hour. Okay, but make sure you're careful about that. 10 hours is 600 minutes. Ella.
So the individual constraints will usually be like an amount of the
Yep.
X and Y, not like time.
Correct.
Okay.
So, for example, if I wrote in here that Mary has to sell at least 2 packs of birthday cards, if that were in here, that's a specific amount for one type of card. That would be X is greater than or equal to 2. If I said Mary cannot sell more than 5 packs of holiday cards, then I would say Y is less than or equal to 5. So I'd have some horizontal lines in there, but that's not the case in this one. Okay? Any other questions about your constraints? All right, so our objective function tells us how much we're going to be maximizing, in this case, our profit. Okay, so Sam, how much does Mary make for each pack of birthday cards?
$2.50.
For a birthday.
Or $2.
$2. So $2 for every pack of birthday cards. And then Caleb, how much does she make for each pack of holiday cards? $2.50. So that would be my objective function. All right, so I'm going to go through the graphing process for this one a little bit faster this time. Okay, so let's find our intercepts. So for these two, my x-intercept is going to be 35. Cover up the y. Cover up the x to find my y-intercept. That would be 35. For my next two, if I want to find the x-intercept, 600 divided by 15 is going to be 40. And then 600 divided by 20 is going to be 30. So when we're making our graphs now, we want to figure out the smallest interval that goes into both intercepts. Okay, so my two x-intercepts are 35 and 40. What's the smallest number that goes into both 35 and 40? 5. So I'm going to make my interval 5. And again, though, just to spread everything out, so I'm going to make this 0. That first little corner should always be 0. To spread it out, though, I'm going to label every other one. So 5, 10, 15, and so on. You don't have to do this. Again, I just really, maybe it's just my eyes are getting old. I like to make things as big as possible. You can make your y interval something different if it makes more sense to do that. My y-intercepts are 35 and 30. What's the smallest number that goes into 35 and 30? 5 again. So this one, it makes sense to keep them the same. But I'm going to do the same thing. I'm just going to label every other one. So 5, 10, 15, 20. I only have to go up to 35 there since that's my biggest value for y. All right, so I am going to start by graphing 35 and 35, my two intercepts, connect them. My next inequality, my intercepts are 40 and 30. zeros. We have to figure out where we're going to be shading now, and then figure out my corner points. So both of these inequalities are less than, so I'm going to be less than this line, so I'd be shading down here. I'm also going to be less than this line. So I was just kind of do that, and then I'll color in the rest. All right, so I'm going to have 4 corner points, my 2 intercepts, the origin, and then this point of intersection here. So the 3 intercepts, or the 2 intercepts and the origin should be the easy ones. So we've got 0, 0, 0, 30, 35, 0, and then it looks like this point of intersection is at 20, 15. So over 20, up 15. But we need to make sure we check it to make sure we didn't make a mistake. So plug that into your inequalities. 20 plus 15 is 35. I'm good there. 15 times 20 plus 25 times 15 is 600. So I know that that's correct. And if it's not, then I would have to set up a system to find that correct point of intersection. Don't get the problem wrong because you didn't take 20 seconds to check your point. All right, so let's see what is gonna make Mary the most money. So if she doesn't sell anything, she's not gonna make anything. 30 times 2.5 is going to be 75. 35 times 2 is going to be 70. And then 2 times 20 plus 2.5 times 15 is going to be 77.50. So it looks again, well, I shouldn't say again, this is the first time we've done this problem, second time for me. When I look at the situation that has the highest profit, this is where it is. So our conclusion is, once again, always a complete sentence describing what should happen. So Mary should sell 20 packs of birthday cards. And 15